Hey guys, welcome to the Code to Coffee, and today we are going to learn the highest mountain problem. Okay, let's start. So the problem statement is you are given an array of integers representing the highest. A mountain is defined as a sequence that strictly increases to the peak, then strictly decreases after the peak. Okay, and this is the array. Okay, so what we are trying to say, let's build the mountain based on this array. Okay, so we'll start with the 5 6 1 2. Okay, so 5 is here, right? Then 6 will be above of the 5, right? Similarly, 1 is the below than 6, so we'll draw like this. Okay, then 2, then 3, then 4, then 5. Okay, then 4, then 3, then 2, then 0, then 1, then 2, then 3, then minus 2, right? Minus 2, then 4. So this is how the mountain will look like. And what we are saying, uh, mountain is defined as a sequence that strictly increases to the peak. Okay, so if you pick this one, okay, so we can say that this is the strictly increases to the peak, right? And then strictly decreases to the peak. Similarly, we can check this one as well. Here, all the this mountain strictly increases to the peak and then strictly decreases after the peak. Similarly, we have another peak as well, like this. But this is not our peak, okay? This is not our peak because here we are strictly increases to the peak, but there is no peak after. There is no mountain after this peak, right? This is not here, right? In that case, this is not the peak. So we have only one, two, and three. Three peaks are there, right? Okay. So our task is to find the length of the longest mountain. Okay. So let's say we selected this is one peak, right? So what is the longest mountain for this? Okay. So if we count one, two, three, so we have only three mountains for this peak. Okay. Similarly, if we will count for this mountain, how many? It will be one, two, three, 4, 5, 6, 7, 8, 9. So total 9 longest mountain are there for this peak. Okay. Similarly for this one, 1, 2, 3, 4, 5. Okay. Total 5. But we need to find the longest mountain, which will be the maximum. Okay, the 3, 9, and 5. Which one is the maximum? 9, right? So our longest mountain in this array is 9. So this is what we are need to find out. Okay. Okay. So how we can start? So let's start from I equal to, let's say we can iterate, right? I equal to 0. From here we can iterate. But if we'll try to see for I equal to 0, this cannot be for the, I mean the first and the second condition is not fulfilling. So no point of taking I equal to 0 for our iteration, right? So we can simply remove this one. So we can start from the I equal to 1 because for this peak, okay, for this peak we have strictly increases and the strictly decreases. Similarly, if we reached here I equal to n minus 1, so there is no point of taking this one, right? Because there is no mountain after this, right? So we are not going to take this one. So we will take only till here, right? I equal to n minus 1, right? Because after that we can check whether it's a peak or not peak, but here we cannot check, right? So our iteration will be from, we can have a while loop or maybe for loop where you can say I equal to 1 to I is less than length of array minus 1, right? And now our next task is to find out the peak. How we will find the this peak? Okay, what the logic we should write. So these two conditions we will try to fulfill to find the peak. Okay. So if this is the I, let's say this is our I, or maybe this is our I, then what will be this index? This will be I minus 1, right? And this will be I plus 1, right? And if you closely observe, what we are saying here in the first line, the strictly increases, we are saying array of I minus 1 is less than array of I, right? This is our first line. Then the second line strictly decreases. What we are trying to say is here, we are saying the array of I is greater than array of I plus 1. So similarly, we can write like this, array of I plus 1 less than array of I, right? If this condition is fulfilled, we can say, okay, this is the peak, right? So similarly, we can check here. If array of I minus 1 is less than array of I and array of I plus 1 as well is less than array of I, right? If that is the case, now we can have the logic, right? Now we find out the peak, right? Now we need to count the number of length. Okay, what is the length? So to find out what we can do, we can go in this direction. Okay, we can go from here, from peak to backward direction, right? So if you're saying I mean j equal to I, so we can start from j, then j minus 1. So if this is the j, and this will be j minus 1, right? Similarly, so what we need to check? So we can just simply check whether it's going in backward direction or not. We can check like if, or maybe within the for loop, because for each time j is decreasing, right, by 1, right? So in the for loop we can check like if array of j, right, array of j is, this is array of j, this is array of j minus 1, right? If array of j is greater than array of j minus 1, if that is the case, we can say okay, it is going to the backward direction, right? So once the j will reach here at this point, right, at this point, what will happen? If uh, if j is reached at this point, then the j minus 1 will be there, this one, right? So if we try to observe, this array of j is not greater than array of j minus 1, right? So this condition will be false for this jth position, right? That's mean at this point our this for loop will be exited, right? Okay, so in this for loop, every time whenever we traverse from peak to downside, we can just simply increase our counter, right? We can have one counter and we can increase that counter. So let's define the counter here. We can just initialize counter with the one. Why one? Because we are starting from here, and this is also we are going to count, right? So we can start counter with the one, and every time when we find the downside, we are going to increase this counter, right? Now backward side is solved, right? Now also we need to count this forward side, right? So let me just, okay, we also need to count this one forward, right? So for that thing, what we can do, because this is the I, right? This is the I. Then what will be this one? This one will be I plus 1, right? So we can check that one as well. For AI is AI is greater than array of I plus 1, right? And in that case, we can again increase the counter, right? Of course, here we are saying I plus plus for each iteration, and here we are saying j minus minus for each iteration, right? So this will be our logic to find the length of the mountain. And every time for each peak, for each peak we will find the counter, right? This counter. So we can simply check for after each peak we can simply check if this counter is greater than the maximum of mountain, right? If it is the greater than maximum of mountain, we can just say max mountain is C. Can check, and this max mountain we can initialize at the top, right? Max mountain equal to 0. Okay, so let's code this one. We'll go to the VS Code. Okay, so this is our array. Okay, and we are going to create one function highest mountain, and similar simply we can just initialize the max mountain with nothing whatever this one with the 0. Okay, now here we'll write the logic. Okay, we'll start with the for loop, where we will say that okay, I is equal to 0 1. Okay, and I is less than length of array length of array as 1. Okay, and then I plus plus. Now within this we need to check the pick point, right? How we'll check? We'll check with the if block like this. If array of I minus 1, right? Array of I minus 1 greater is less than array of I, and array of uh, I plus 1 is again less than array of I. If that is case, we found the our peak position, right? And then we need to initialize the counter. So let's initialize counter equal to 1. Then within this we can simply have a for loop, and we'll start with the j equal to I, right? And then this j should be always less than length of, because okay, j should be greater than 0. Why 0? Because j we are decreasing, so it should not reach till here, it should be always till here, right? So you can check this one, and then we can have this condition where we are checking array of j is greater than array of j minus 1, right? So array of j is greater than array of j minus 1. If that is the case, we need to decrease the j and we need to increase the counter, right? So we can say j minus 1 and c plus 1, right? That's all we can do. Let's save it and and just copy this. Here we will start from the I. So I we do not need to initialize because we already have this I, right? But we can just check I is greater than, it should be less than length of array minus 1. And here array of I should be always greater than array of I plus 1. Then array of, and then I should be increasing, right? So here you can say I plus 1. So at this point we found this counter. Now we can just simply check if counter is greater than max mountain, then the max mountain is counter, right? and yeah, we are printing this max counter, right? So let me just run. Okay, so the longest mountain is 9 that we found here, right? Okay, so we found our longest mountain. Now, if we see here in this code, we have one for loop outside, then the one for loop inside. Okay, so one for loop is for selecting the peak. Okay, then other for loop is just counting the mountain, right? So if we try to understand, the complexity is our the time complexity is n square, right? This is our time complexity, right? Space complexity, we are having the constant, right? Order of 1. So can we do anything so that we can, optimize the time complexity, right? So let's discuss this one. Now, we have one algorithm, we say the Cadane algorithm. Basically, what we do here in the Cadane algorithm, we'll start from, from I equal to 0, and we'll to try to understand at this index, what is the count, okay? At this index, what is the count? If, let's say, at this index, the count is 1, right? And if this index, the count is, you know, 2. At this index, the count is 3, right? Now, when we'll reach here at this index, now this because from here till here, it's our mountain, right? This is, we say it mountain because it's increasing and then decreasing. But once we reach here, right? This is not the continuity of this mountain, right? So basically, we already broken this here. So at this point, when I was here, when I was here, what is the count? At this point, our count is 3, right? So we can have one max count or max length is 0. We can check whether which one is the max, whether this one is the max or this counter is the max. And whatever the max will be there, that we will update here. So I mean, so 0 to 3, because it's a 3. But how we will understand that this point, at what point we need to check whether the max count and the count which one is the maximum. So let's say if this is the I, right? If this is the I, if this is the I, then what will be the index of this and what will be the index of this? If this is the I, then this will be I plus 1, right? And this should be I minus 1, right? If that is the case, we can simply check if array of I, if array of I is less than array of I plus 1, and array of I is again less than array of I minus 1. In that case, once we find this condition, in that case, we can just update this max count equal to maximum of max count or counter, right? If that is the case. Now, and also because till now the counter is 3 and this counter will be goes into the max counter, and what we can do, we can update the counter equal to 1, right? Because now from this point again we need to start till this in this direction, right? So we can start c equal to 1 from here. Again we'll go to here, c equal to 2, c equal to 3, 4, 5, 6, 7, 8, 9. So once we reached here, again this condition will be fulfilled, right? In that case, again this counter will become 3 to 9, right? And again this counter will be updated to 1. So again the counter will be 1 here. So let me write. The counter is 1, then 2, then 3, then 4, then 5. Again this is here, but because the 5 is not greater than 9, right? So we are not going to update. So again I mean, this condition we are not, I mean, this we are not going to update, and this we can update because this we are holding, right? So if that is the case, we are saying, max count is the maximum of the max count and the counter, and after this we can simply, you know, update the counter. So again here C will be 1, but and C equal to 0, so it will be 2. So this is how we are going to do. Basically, in the earlier, we were relying on the, peak point, right? Peak point. And in this approach, we are calculating the down point. Is the down point. Which will be the down point? If the previous one and the after one is the greater than, then this is the down point, right? So this is how we can do. Now you can see our iteration will start from I equal to 0 and it will go till here, and there will be no any other for loop, right? So the complexity will be order of n on, right? Okay, let's code this one. So we can have one more function. You can say the function cat highest in, sorry, can mountain, right? This will also take the array integer, right? And again, as we print this one longest mountain, but with okay, size this mountain is equal to 0, right? Let's write the logic what we discuss. Okay, so we can start with the for I equal to 0, and I equal to 1 actually, because here we are checking I minus 1 and I plus 1, right? So it should be like I equal to 0 and I is less than length of array 1 and I plus plus, right? Every time we also need the counter, so you can say counter is equal to 0, right? Okay, counter equal to 0, and okay, we just need to check this one. So prior to checking this one, we also need to update, okay, because this is I mean our counter, right? For each iteration we need to increase, right? We are increasing like c equal to 1, c equal to 2, c equal to 3, then we are checking this one, right? So similarly we can just update counter equal to counter plus 1, right? Counter equal to counter plus 1, and then check if array of I is less than array of I minus, and array of I less than array of j plus 1, right? If that is the case, I. If that is the case, we are just making c equal to 1, right? Now, also we can just check if c is greater than max mountain, right? In that case, max of mountain to c, right? I think so. Let's run this. And let's first call this. Okay, so here you can see Kadane longest mountain equal to 9. Now, one more thing. We have this, if you see this third line, okay, it has at least three elements, right? That's mean if we have at least, we should have at least three elements, right? But what if we don't have this three element, right? Let me remove all these things. Then what should be the value? Okay. So if you see, basically we have these two mountain, right? So in that case, this first and second will be, I mean, first will be follow, second will be not follow, right? But what if in some scenario we don't have these two condition? We just need to find the number of mountain which is the maximum, right? And we don't have these two condition given. In that case, the result should be two, right? One and two, right? So if you remove, let me run. What will be the output? Okay, but in our case, we are getting zero, right? Because we are holding these two, you know, condition. But what we can do so that it should also count those things, right? So what we can do here, because we are starting from the I equal to 1, right? So you can start with the I equal to 0 and and e, okay, say this condition we can put here, right? So to be greater than 0. Again, now our cadena is giving the correct, right? And what if I will remove one more very, okay, here, right? If I remove this one, it should give the 1, right? So yeah, we are getting the 1. But what we should do here to fix this, right? Keep it. Simply we can write like if length of array is less than or equal to 2. Okay. In that case, we can have the max count equal to length of array, right? Then just simply, and if we run this, now you're getting the correct, right? Of this. Now we are getting the 1 1, right? So this is how we can, just have a generic, uh, you know, the, the mountain. Okay, let me again just check again whether it's working for everything or not. Save it, run it. So yeah, working for these things. Okay, so we discussed the two approach. Okay, one is for detecting the peak, then going to the backward and going to the forward. But this is bit costlier because we are having the order of n square. Other is the Carania approach. So every time we are going to count the mountain, and we are going to stop counting once we find the lowest mountain. Okay, and this is the condition of finding the lowest mountain. And every time we can just check which is the maximum, whether the max count, the previous count one, or the current count. Whatever we will get, we'll be storing that thing. So that's all, guys. Thank you so much.